today we're very pleased to talk to Eelco and hear about the space weather tools from Europe and how they can be used and appreciated by Aurora chasers, and to really, I think, please forgive me because I don't have your bio in front of me. So, but fill us in and tell us more about your specialty areas, because I know you're also an expert in the ionosphere, and there's a lot of overlap with our group here, which always has a great mix of amateur, professional Aurora enthusiasts. So we can have a good discussion today, and maybe tell us if you want questions throughout or how you want to handle that too. So thank you.
Yeah, questions throughout is good. Yeah, thanks for the introduction. I have also a slide. Let me see. You can see my slideshow now. Yeah. So I will switch between the slideshow and the demos, live demos.
Great.
Which is always a bit dangerous, especially as I've been tinkering with the software today to try to get to show some new stuff. There are some things that I need to demo that are not yet available on this computer, so maybe I have to switch halfway to sharing another screen, but we'll see how it goes. So I'm very happy to be here. I have this outline. I'm not sure I'm going to get to spend a lot of time on all of these because it's a lot the way I see it now, but I have some slides on my background and the inspiration for building the tool. I want to give a demo of the basic functionality. And then there's this feature that I worked on with Jeremy to get to play YouTube movies in the timeline viewer that I'm very excited about, and I think it's very cool. And I've actually been playing with it again today and trying to make it a bit better. And then I did some worked on a paper last year about the May 10/11/2024 aurora, and I used the timeline viewer for that myself. So I can show you some of those observations, of course, which are quite nice. And I want to end with some plans for the version 2.0 of the timeline viewer that I've started work on recently. And then, of course, questions and discussions. But actually, my implementation of the timeline viewer 2.0 is now broken, so I cannot really demo that because I've been tinkering with it during the week. And somehow I broke the code, and today I did not have, and this week I did not have the time to to fix everything in time. I guess that's okay, because otherwise we will run out of time. So a little bit about my background. I did my MSc in aerospace engineering on Delft University of Technology. And I did a thesis project there on satellite aerodynamics. So air resistance basically on satellites in low Earth orbits, basically below 1,000 kilometers in altitude of these satellites. That's important. And I worked on precise orbit determination for Earth observation satellites, for which we need to have like centimeter level accuracy knowledge of where the satellites are for their measurements, for example, for sea level measurements and things like that. So that's how I started my career. And yeah, very quickly I realized that basically the tracking data from those satellites, so the GPS receivers on the satellites and the laser ranging data on the satellites, it provided more information about the upper atmosphere than the other way around, which was my starting point, that yeah, we should improve satellite drag models. So I turned my research around and sort of tried to pull out data on the space weather in the upper atmosphere from the motion of the satellites. And that led to my PhD thesis and a couple of projects for the European Space Agency, who happened to be working on satellites with very fine measurements of accelerations, the GOCHA and the SWARM missions. I moved from TU Delft to the Royal Netherlands Meteorological Institute in 2019, and I'm working there now as a space weather scientist. So that's a much more general, so I was very focused on a sort of the specialist topic of satellite drag before, but now I need to know basically everything a little bit about all parts of space weather. Yeah, I think that's very nice. We're a very small group. We're just with 3 people who work full time on space weather in the Netherlands. And during a week like this, we get a lot of questions, and yeah, we put out advisories, and we get phone calls from the media, but also from government and from potential people who have vulnerabilities in their systems. Nothing much has ever happened in the Netherlands in terms of space weather impacts, but still, yeah, we need to be prepared for bigger events, and people are interested in this, so that makes my work interesting. And of course, there are always impacts on very specialistic applications like surveying with GPS and things like that. So I have a passion. Yeah, sorry.
Sorry, you were probably about to say this, and you're also on Twitter.
I'm not on Twitter anymore already.
Oh, okay. You and I are both, I think we met on Twitter and we're not on Twitter anymore. Okay.
Yeah. No, I left that behind. It was getting a bit too too crazy for me. But I miss it sometimes. So I have this passion for work on data visualization, which I will talk about today, and making tools for exchange of data and combining different types of data. And that leads me to the timeline viewer. And inspiration for that basically is my old-fashioned love of maps. So I said already as a kid, I loved looking into atlases and different kinds of maps, historic maps, thematic maps with data on it, and different scales. And then in the internet era, of course, applications like Google Maps came along, and this was really like a dream come true for map lovers, that you can travel around the Earth and look at the world in different ways. And it allows you to zoom in and out so easily. And then, of course, my career, I was looking at data all the time, and mostly time series data, but also, moving pictures that represented time progressing. But the existing portals for this data, they always were a bit clunky. I felt that they could be better. So that's why I wanted to basically combine the ease of use of interacting with maps on applications like Google Maps with the data from the space weather domain. And the goals for the development, you can already see these are really old movies from, I think, version 0.1 or something like that of the timeline viewer. But it still looks pretty similar. It works on the phone, it works on big screens that we have in our office. But the goals were to make it easier to monitor space weather observations and forecasts in real time. So whenever something's happening, I can just glance at the screen or at my phone if I'm in transit. And yeah, that's very nice. It's also very useful for training and education. So I started really working on this in 2019, and it was solar minimum. So if you start a space weather job in solar minimum, you can look at the NOAA website all you want, but you won't learn about CMEs or about events like that. So you need to be able to look back in time, and I think that's also where the tool comes in very handy. Verification and validation of space weather advisories and models. So I did a lot of work for the European Space Agency. They're always interested in looking at the strengths and weaknesses of the data and the models that are made from the data. And of course now there are also space weather advisories, like we give a heads up that a geomagnetic storm is coming. How can we use these tools to check whether our warning was good or not? Did we get it right? Where can we make improvements? So that's also where the tool comes in helpful. And then data exploration for space weather case studies. Like if you want to publish a paper on the May 2024 storm, like I did, submitted the paper a couple of months ago, then yeah, it's a good place to start to see which data is available, what are the key times that you want to look into, where were the satellites, etc. So I have a couple of slides that are basically reminders for me to go over when I give the live demo. So let me switch to the timeline viewer and make it full screen. And let's see. Yeah, this is basically the home page when you open it, and it's just a browser application. Yeah, you can go to it via this URL, spaceweatherknmi.nl/viewer. I can use the standard options in the browser to make the font bigger and smaller. So that's basically here in the menu as well, actual size and zoom in and zoom out. So that it's easier to read if you have people looking along, or that you can make the fonts very small if you just want to focus on the detail in the data. Yeah, so the main, I think, best thing about this is that you can very smoothly go through the data, look back in time. Normally, when I give presentations, I have to start scrolling back to show something interesting happening, but you can see this week was very interesting. This is exception that I can just open the homepage and there's events happening on all the rows basically in this view. We get the solar flares on the top, the energetic protons in the second row, and then the interplanetary magnetic field and the solar wind speed below that, and then the KP index at the bottom. And especially this KP index, it's useful if you zoom out. You can see that it loads basically the peak KP index for the day if you zoom out to years, and then over a period of a couple of days. So that makes really these big storm events stand out. If you want to look for the May storm, you can already see it's here, and you can just position your mouse over it and scroll the mouse wheel or do this on your trackpad, and yeah, you get very detailed data of this May event. Yeah, as you zoom in and out, basically higher resolution versions of the data get loaded. If you zoom in, if you zoom out, it goes to lower resolution, and that keeps it snappy, responsive. You can also see these little half circles here on the x-axis. This is something you can click on, because on this particular type of plot, I have Enlil model output of the solar wind, speed and the total magnetic field in the solar wind. And basically this location of this line and the filled dot indicates the approximate time that this model was released. And you can see, so a couple of days before these storms hit, we did not know anything was coming yet. And then if I step forward in time, you can do that also while hovering with the mouse with the left and right arrow keys. You can step through the different simulation runs, and you can see basically what the models were expecting. And this particular storm, of course, arrived a couple of hours earlier than expected from the model run, and it was much stronger in terms of total magnetic field. But you can do this for every, you can do the same thing very quickly for the October storm, and for last year and for last week's storm, like this. So that's the basic functionality on the front page. Then there is this a button on the top left. Actually, there looks like two buttons, but the right one is not the button. It's just an indicator of whether data is loading. So you can see this number appearing whenever it's loading new data. But the bookmark icon, it basically leads you to a list of bookmarks. And there you can switch to different layouts. So this is the layout for the solar cycles. Here again, you also have a solar cycle prediction. So you can step through the different months that the Marshall Space Flight Center put out these solar cycle predictions. If you zoom in, you get the daily values, and if you zoom out, they disappear, and you just see the smooth and the monthly values. If you zoom out all the way, you can go back to the 18th century and see what the solar cycle was like back then. Of course, there are many layouts here, and there are also a lot of them for projects that I'm working on, and some that I have still labeled as experimental layouts. Yeah, at some point I need to clean this up, but I will go into two different layouts during the rest of my presentation. Let me see. Oh yeah, so the magnetometer data, and then the layout editor and the dark mode. So there's this magnetometer layout, which I think might be interesting for Aurora chasers as well. It basically shows in the top row HP30, so the 30-minute version of the KP index basically. And this is taking data from servers that are not our own. So for our own server, I have yeah, I should be more specific. So for the HP30, that is on our own server. And that means that if you zoom out, it has these lower resolution versions of the data. And then it can keep showing the data and still be very responsive. The magnetometer data comes from different servers, from the SuperMag project, from the Intermagnet database, from the NASA CDA web. and it does not have these lower cadences. So you have to sometimes zoom in quite far to be able to see the data, but then it loads and you can check it out. And I have to move some of the zoom stuff out of the way to be able to see my own legends here. But the top row is HP30. The next row basically contains a couple of magnetometers, magnetic observatories from Intermagnet that are used for the AE indices. And the AE indices in live are not available in the timeline viewer, but if you go far enough back in time, let's go back to the May storm. You can see also these filled areas. Those are the AE official AE indexes and the SuperMUC versions of those. And you can see that they basically are an envelope for these individual magnetometer contributions. So they contain the minimum and the maximum values of that. But unfortunately, not all magnetometers are available on these databases. Well, they probably are for SuperMAC, but I have not implemented that yet. And then the third row is the ring current indices, so DST and SIMH. And you can look at the differences between the different versions of those. And then in the bottom row, I have this north-south line, basically sort of stack plot of magnetometer data. And this basically, for example, you can zoom in here on this time period where even at the magnetometers in France and the south of England and Belgium, there were quite large variations. So this was probably the most intense period in Central Europe for this entire storm in May. There's also a layout editor, and this is sometimes a bit buggy. So not all the features that are available can be changed from here, but a lot of them can. So you can drill into global settings where you can change the margins, and you can change the zoom detail factor. So that's basically, it works best on another layout, but that's, so let me go back to the real-time one and zoom out a little bit. So sometimes it looks a bit clunky with the low resolution data. And then with this zoom detail factor, if you crank it up, it loads the higher resolution versions earlier. So if I crank this all the way up to 32 or something like that, it means it's loading 32 times the normal amount of data. But then it gets a bit laggy. I don't know if you can see the difference over Zoom. Yeah, I see a lot more delay when I drag the mouse now that I have this high resolution data loaded. So it's best to keep this low while you're playing with it. And then if you want to make a screenshot, then you can crank this one up. Then there are some experimental settings, but you can also drill into each of the individual subplots. So these are these big headings here, which correspond to these rows, and you can turn them on or off. You can hide them and turn them back on. Sometimes you have to move the mouse a bit. It's also a sort of bug to get the data to reappear after you've made it visible again. So now nothing is showing, but as soon as I drag the mouse, it loads the data again and it shows it. So here also you can change the geometry, so the margins for this particular row, you can drag up and down. You can change the height of the row if you want to really see more detail for this particular row. You can change the titles. So if I type here, you can see it reflected there. You can turn on and off the legend and things like that. The y-axis, you can change the values there. If you want to zoom in on that, you can turn on and off the axis and the spacing on the y-axis. So if I drag this one, you can see tick marks and things appear or disappear to make it busier or less busy. And then for each of the plot elements, you can also, hide them. Let's see. I have to go to the current data to show that you can hide it and show it, because the older data is from a different data set, but it seamlessly looks the same. And here you can check or choose where you want to get the data from. So there are a couple of servers here, quite a lot. Our own server has many different products that you can choose from. But then, for example, the NASA has even a lot more. So they have a very large catalog of all different sorts of missions. I think most of them I don't even know what they are, but you can see the different generations of Ghost satellites. Giotto, which was like a cometary mission in the 1980s, I think, etc. So you can browse through this and see what data is available there. And if you selected the data set, I think this is the wind data at the bottom. You can select a data set and then select the x-axis data and then the y-axis data. So this is the wind L1 satellite, so basically the predecessor of ACE and Discover, which has solar wind parameters and solar wind pressure and things like that. So I think that is most of what I wanted to show in terms of basic interaction. I don't know if there are any questions at this point. Otherwise, I will move to the next part. It's always...
There's one in the chat, I think,
okay.
About whether you can specify the start and end times. Yeah, how to do that.
Yeah, so that's basically not... so the only way to do that is to basically zoom out with the mouse wheel or with the trackpad, and then go to the time you want to go to on the x-axis. So let's say I want to go to 2010, and then I zoom in with the mouse, and then I want to go to, yeah, there's an X flare here that I want to see. Well, there's no data, no actual time series data for 2010 right now, but so that's basically the way you do it. And if you want to go to 2023, there were some storms and activity, I think, in April. So you can just drag and scroll, but there's no sort of calendar pop-up where you can type in a date or select a date on the calendar. So that's actually a feature that I have been working on already, but it's going to be in the Timeline Viewer 2.0 that I will discuss shortly at the end.
Well, it's so easy to use. I think that's really great.
Yeah, so it's basically, you have to think about it as you would in Google Maps. Of course, in Google Maps, you can search for a location, but you can also just zoom out from the place where you live, see the entire Earth, go to some foreign location and zoom in all the way to street level there. So if you think about it like that, it's very easy to use. But I get this question quite a lot about also people wanting a calendar date picker or some place to type in. So that's going to be added in version 2, which will come out next year. So I will go on to the Aurora demonstration. So this is a portable, you probably all know it, I guess, portable ArcSky camera system developed by Jeremy. There's a special layout for it in the Timeline Viewer, and it allows you to switch between movies, change the time where you're playing in the movies. And today I also added the feature to show the location of the movies on the 3D globe after a short email discussion I had with Jeremy earlier in the week. And I also made a version of this layout for time lapses that my colleagues for my institute took in May. So let me see if I can actually get this experimental version working. No, it's not yet ready. So I'm going to quickly switch sharing to my other computer, because there I have it. If I can share here, yes. Oh, I have to change the system settings. So give me a minute and then I'll come back. I have to give some permission.
We will just complement the tool in the meantime. I think it's really great how things are laid out in just a functional way that's really handy and exceptional, actually, in my opinion. Let's see, intuitive exploration. Yes, that's what's
I really
cool
like
about
that.
it.
I struggle a lot with aurora science and particularly space weather forecasting stuff because I do not have a science background, but this looks understandable to me.
So I think in the thanks for that. So in the meantime, I think you're seeing my other screen.
Yep.
Yeah. So this I have been developing this new feature on this today, and I did not get it to transfer to the other computer in time. Let me see. So this is a layout which in the top row shows the globe, and that's something that I usually use to show satellite orbits. But in this case, it also can be used to show the locations of where the Aurora cameras were installed. And if I zoom all the way out, you can see in 2023 and 2024, there are a lot of movies like that. And then if you zoom all the way in, you can see how long these movies lasted. Let me zoom into an interesting event here. Let's take the May storm again, because that's a very nice one. Yeah, then you can see at the bottom two rows, you can see two magnetometers. But I can turn one of them off because this computer has a little bit of a small screen. Let me also see if I can fill the entire screen. No, this has changed in some way. Here, full screen, entire screen. Yeah. Yeah. So let me just turn off one of the magnetometers, and you can see it's a bit hidden, but on the x-axis, basically, you see these intervals, and those are intervals where the YouTube movies are available. And if you click on them, they start playing. And you can see this timing indicator moving, and this is basically a YouTube player built into the timeline viewer. And you can then relate the time where these recordings were made to changes in the interplanetary magnetic field or in the ground magnetic perturbation. So here we see a big substorm onset, I think, and you see the corresponding magnetometer readings. You can see here on the map that this one was in the western part of Canada. Maybe one of the participants to this meeting made this movie. I don't know exactly who made this, but you can also switch between the different movies, and then you can see the location light up where the movie was made. So this is a feature that was added today. You can also see that this particular movie, it starts when the sky was still quite bright, so just after sunset. And you can see also on this map, the shadow of the daylight and the shadow corresponding to that. So you can see it getting darker, moving into the night. You can see one of the swarm satellites passing over North America at this location. And then on the right-hand side, you can see this the aurora happening there. So to restart the movie, you actually have to click on another one and then click back. So there's a few bugs here, so that's why this is still listed under experimental. But you can also pick up this time indicator and drag left and right, and then you can see where the satellites are. But you can also see the movie respond to that. So let me just pause the movie by clicking on it, and then you have to get rid of this YouTube feature that is a bit annoying. So if you drag very fast, you don't really see the movie changing. But if you keep the mouse still for like a millisecond, a few hundred milliseconds, like half a second or so, then the movie also switches to the frame where your mouse is hovering. So you can very quickly look for interesting times and events, also in relation to where satellites are. So I don't have the satellite data displayed here yet, but this is something that can be very easily added as well. Yeah, so I think this is very interesting to study, what's happening in all-sky cameras. For me personally, I really like this, to be able to witness what the aurora looked like in a place like Canada, which is very far from where I live. And also for me in the Netherlands, it's not that easy to watch the aurora, and also it looks very different than at more northern magnetic latitudes. So I can just maybe show a few other movies here and drag to where it gets interesting. So here you see the aurora on the horizon. and it's moving south very slowly. So you can see also in this movie, I think Jeremy made this very nicely, this kilogram type clock around the movie. So this, maybe I can quickly show how this is done. So in this editor, there's also at the bottom a button show layout. And that basically shows all the settings that go into, what to visualize and how to visualize this. And if you scroll a little bit down in this, at some point you get this item called YouTube movies. And then it basically shows the YouTube movie ID. So that's basically the identifier for YouTube. If you browse YouTube, you will see this identifier also in the URL of your browser. And then we added some metadata, the start time of where the event is happening and the stop time in the movie. So this is in seconds into the movie. So this movie lasts about 53 seconds. And then you can map these start and stop elapsed times to UTC times. So here are the timestamps in UTC for when this particular movie started and stopped. And then there are just, I think maybe a dozen or so different movies now. And of course, it's very easy if you upload a new movie to YouTube to add this information. It takes a little bit of time to figure out these elapsed times and start and stop times, but it's not that difficult to add new movies. So that's also what I did when my colleagues made time lapses from the Netherlands. So they are not experienced auroral photographers at all, but I could give them a heads up that something was going to happen on May 10. And this is the other layout. I don't know why it now opens in August, but it should open in May. And there are only two movies here from two of my colleagues. So this one is from the city center of Utrecht, which is quite close to my office. And it shows basically what the aurora looked like from the Netherlands on the 11th of May, 10th and 11th of May. So the time here is in local time, and here it's in UTC time. So that's why you see this difference. And this gives me also the opportunity to, I was actually not in the Netherlands at the time. So this gives me an opportunity to see what it looked like. There's another one here. This is a colleague of mine who works on the meteorology for the airport in the Netherlands, Schiphol Airport. And it's a very light polluted place. So all this orange stuff at the bottom, it's all light pollution, but still you can see the greens coming through. And then when the storm starts to kick in, you actually see these curtains and different colors starting to appear. And again, towards the end of this movie. And I think this is very nice to be able to show people what a special event this was. Any questions about this?
I can probably get you some other exceptional videos from Europe for May 10th.
Oh, that would be great. Yeah. If you have them with proper time text, then yeah.
Yeah, there's an all sky from one of our collaborators in Germany that would be really nice. So we can talk to them about that. And I was also wondering, is the code open source in any way? Because it seems like it is. Has it been used by like other geophysical kinds of folks or like adapted in any way?
Yes, so actually my colleagues at my institute, they are working also on a sort of meteorological scientific satellite called EarthCARE, which measures properties of clouds and aerosols, and they've adopted it. And also, several people have been interested in using it for space weather, but with their own customizations. So that includes sort of space weather enthusiasts. There's one in Germany I'm in contact with who has set up his own website. I don't have the address right now. But also SWIPSI is using it. So NOAA Space Weather Prediction Center is using it internally. And they're working on actually making a new version of their landing page for the real-time solar wind data that hopefully is going to make use of this way of interaction.
My, that would be fantastic.
Yeah.
That would be like a multiple decades of advancement in one fell swoop. That would be cool.
Yeah.
But also then we would, nostalgically want the old version too. You'd have to have the decimated, pixelated version anyway.
Yeah, we should do maybe some sort of
Vintage.
archiving of for memory's sake. Yeah.
Mm-hmm.
Yeah. So this is a short part of the what I wanted to show. Also for the Netherlands, it's basically as I said in the beginning, we don't have much space weather impacts, but of course we know the stories about the Carrington event and the telegraph wires and everything that happened there. And always the horror story basically is, what if a Carrington event would happen today? We don't know actually very well. There's the possibility to do simulations and things like that. But if you look at the data from the Carrington event, it's basically this anecdotal data of where the aurora was and what happened to the telegraph. And I think it's very interesting to put this in sort of historical context. So these are pictures from Hayakawa et al., who sort of made these anecdotal sightings of the aurora from all these papers that were also published in the 19th century. And you can compare this very nicely to this paper by Grandin et al. From the Arctic Survey and Skywarden. And yeah, it looks pretty similar. I think in the 19th century, there are a little bit more low latitude locations like here in Cuba and Central America, but not that many. And also what I find interesting here on all these islands in the Atlantic, there are observations that were sent in. And of course, there are now more people living on islands in the Atlantic, but apparently they are not yet engaged with these types of surveys, or maybe there were clouds, or I don't know, but or maybe this was just not too bright an event compared to the Carrington event. But that's the main difference that I see. And then of course you get this comic from XKCD about what would happen. And yeah, that's basically what our worry is in the Netherlands, that we don't really know what would happen, but how does an event like May relate to an event like the Carrington event? That's basically a question that I looked into. And of course, these observations, they do not necessarily tell you the location where there were the big currents overhead that are dangerous to the power grid. So that's basically what I wanted to know. How do these observations from 1859, but also from 2024, relate to power grid issues, potential power grid issues? And then you want to know where were the auroral currents overhead? So that's basically also where I made a couple of layouts for the timeline viewer. So let me go back to that one. Starting with the GOLD satellite. So this is a NASA satellite that was that's basically from geostationary orbit, is looking at the Earth, and it's making basically the first that I know of pictures of the aurora from the side on a continuous basis. And I think this is very interesting. So let me just start with like a couple of days earlier, there were like normal geomagnetic heightened geomagnetic activity. Maybe this is a good example where it's at the end of the day, because this satellite only makes nighttime measurements, for a few hours, because otherwise the sun is in the field of view of the instrument. And there you can see very faintly that there's this aurora basically from the point of view of the satellite just south of Greenland, but it's not very bright. And then if you go to the May event, it also does not go very high. If you go to the May event, what I found really interesting is how high actually this aurora extends from the surface of the Earth. And you actually see sort of a hint of, I don't know the proper terminology, maybe the aurora curtains, or basically these field-aligned structures. Here in this particular picture shows up very nicely, but also in some others. So you can also go to the next day where it was a lot less active. So that's one different way of looking at the aurora. Yeah, like here at the South Pole, you can see also, and here at the North Pole, this sort of field-aligned structures occurring. Then there's also these types of maps. So again, these red dots are citizen scientist reports of aurora from different locations. And then they are put on a map of satellite. Um, these are the day-night band pictures from the FIRS instrument that are on 3 different satellites. And if you move, I think I will not go too long on this, but you can play around this yourself. You can basically see that in North America there are some locations where people saw the aurora towards the south. I think in Europe it was mostly people south of the aurora looking at it on the northern horizon. Of course, this, as you can see, that it's quite limited. You don't see the entire nighttime sky covered by these satellites, but still, I think this is one of the things that we can do at the moment while we wait for future satellite missions that are in higher orbits that have a sort of full view of the auroral oval. Hopefully, at some point in the future, 24/7, there are mission ideas both on the US and the European side that still have to get funded. But if it gets funded, would be very interesting to also, put into a view like this. So I did not put these images into all the time. So this requires a lot of processing. I have them here also for the Southern Hemisphere, where you get actually a lot better coverage. And it's in a projection that's very often used by space physicists, where you basically, for the South Pole, you look like the Earth is transparent towards the south. And also the continents look a bit distorted because they are transformed into geomagnetic coordinates. So all these blue circles are lines of equal geomagnetic latitude. And that allows you to basically compare what's happening in the Northern and the Southern Hemisphere. And sometimes you see very similar structures. They're not taken at exactly the same time, but still you can look at some hemispheric differences and similarities sometimes with these types of data as well. So I have these for a couple of big storms. I've processed the data, but yeah, for some other storms, I think for this one, yeah, you don't see any data. That's just because I haven't processed it. And then for October, I think I did. Yeah. So this was the October storm. And there you also see some moonlight on the clouds in the Southern Hemisphere. So that's also a disadvantage of this type of data, that sometimes you get this difficulty of distinguishing what is aurora and what are moonlit clouds.
Should I ask a question about that?
Yeah, sure.
Yeah, so this view is, or you said you have to process the data. So this one's not real time, right? But is there an easy way to tell like what is available real time versus not?
That's a good question. No, that's not easy. So one thing that you can do is for a certain data product, and it's a bit messy to be honest. You can look here, there's a dataset start and a dataset stop. So for this particular dataset, the latest data is from, what was it, yesterday, 2 days ago? So that's actually what you asked about at the beginning, if I have some recent data. So, so that's basically where you can look what are the minimum and maximum dates of where data is available. But it's still quite hard if you have these gaps in the middle to know why are these gaps there. So that's maybe something that also I can think about improving in the future. So this was the event of November 12th, just a couple of days ago. So I think it was very quiet beforehand. So you also see a little moonlit clouds here. You see a very slight hint of aurora in the northern hemisphere there at about 70 degrees magnetic latitude. But then as the storm sets on, you see this very quick, very bright substorm onset that was caught in this northern hemisphere pass very nicely. And then in subsequent passes, you see that it goes equatorward. So here you see it passing over Scotland and Denmark. And then further passes, you see the bright part getting narrower and then move into, as the satellites move into covering North America. You can see it quite nicely here north of the Great Lakes. of Canada. And brightening again as the satellite passed towards covering Alaska as well. And then you can also see sometimes these curly structures starting to appear towards the end. And it's also very interesting to watch what happens after a storm, because then you sometimes see the most beautiful, not so straight anymore, these structures starting to appear and disappear. Of course, we had a sort of second night of storm as well here. So this is basically the latest data. There's
You
one.
have a couple of questions in the chat, couple of awesome questions.
Okay, go ahead.
From Vince, can you compute conductivity maps from VIIRS?
I don't think so. So these are visible channel instruments. I'm not an expert on this part, but I think what people have done in the past to compute conductivity maps from aurora imaging was from Goofy and SUSI instruments on the DMSP satellites and on timed. And they monitor in the ultraviolet. So this is visible. They had ultraviolet sensors. And in the ultraviolet, you can distinguish between the different species, between the oxygen and the nitrogen. And I'm not completely sure, but I think you need that to do the computation of the conductivities.
Yeah, I think so too. I think you need the two, like the long and short wavelengths or something like that, maybe.
Yeah. You need to do the combination of different bands, and this is just one broadband visible sensor.
And the color that you have on there is a false color, right? It's it's just a color scale. It's not just brightness with okay.
Just to give a little bit more contrast to the pictures. Yeah.
And a question from Jeremy about whether you've had any serendipitous discoveries while working with the viewer.
Well, I think so. My background in most of space weather is so I'm more a generalist. So whenever I find something interesting, it's usually somebody else has already looked at it in detail. But I think there are some things that if you look into literature, the people do not really use the same type of data. For example, here at the end of the storm, this is just before the second part, you see this polar cap structures. And if you look into papers about the polar cap, they all use these DMSP data. And those are because it's ultraviolet, it's a lot fainter and not as high resolution. And so here you can really see very high resolution polar cap structures. And I don't think there are people who have written papers about these structures in so much detail yet. So I think there's work to be done, but then I'm too busy to do the work. To get people interested in this type of data.
I imagine you also find like various code errors and things that are discoveries, but are perhaps less exciting in that sense.
Yeah, maybe. Yeah. Yeah. Yeah, for the Aurora, there's one more thing that I can show if I can find it. Yeah, this one. I should also go back to May 2024.
I think we also have, I just looked at the time, we have like 5 minutes. So
yeah, let me just quickly show this and then so crank up the detail factor here. So basically what this shows is as a function of magnetic latitude. At the bottom, it shows these 3 VIIRS satellites that I just showed. But now I just took the brightness from the middle of the track as it's going from north to south. And I plotted the brightness as a function of magnetic latitude. So I did some binning for that. And then these little colored circles are these Grandin data set that I showed earlier as well for the southern hemisphere here and for the northern hemisphere here. So here you can see basically Europe and North America, and here Australia and New Zealand. And then you can see basically how bright and how wide the aurora was for each pass of these satellites. And then at the top, I have the magnetometer data from the swarm satellites that measure the field-aligned currents. So they basically measure the magnetic perturbations in the magnetic field, because there are these vertical or field-aligned currents going into the upper atmosphere. So these are the particles that are responsible for generating the aurora. They also generate these currents. And you can basically see a very nice correspondence with, how northward or how southward these currents. So before the storm, you see them around minus 70 degrees here, for example, in the southern hemisphere. And then as the storm starts, we basically see it go towards the equator, reaching, minus 45 and plus 45 here in both data sets. So this is also a way to quantify where the visible aurora was, at which magnetic latitude did we see overhead aurora, compared to these citizen scientist reports that sometimes see a sort of glow on the northern horizon or the southern horizon. Yeah, so that's I think basically as far as I wanted to go for the demo. I think I have a few more slides. My presentation is gone. Oh, here it is. This is, I think I all did all this. So I think the conclusion for the 2024 event, if you overlay this geostationary plot, was that it was cool and exciting, but we did not have to really answer a bunch of open questions in solar terrestrial physics. And then I have some plans for the timeline viewer too, and that is to basically, I will just put this up, but not discuss it in detail, to make it more accessible, to add documentation, to make it easier to resize and reorder elements and import elements from different layouts into other layouts. And also to improve the map, because now we have this 3D globe, and then it's sometimes difficult if something's happening on the other side of the world. So I've already started working on the map projections. And I wanted to
Very
give you
cool.
a demo, but it's not working at the moment, and I did not have the time to fix it. But if you have...
That was a great demo. That was a great demo from what you have.
Yes.
We're actually not seeing your screen anymore. I don't know if you were putting up the slide or something.
Oh, yeah.
Or
Oh,
I
sorry.
don't think so. Unless
Yeah.
it's me.
So this is the last slide. It's basically...
Great. Yeah, this is all
It's
great.
important because it has my email address and the web address for where you can get the software and submit issues if you want to make suggestions for improvements or report bugs and things like that. Yeah, so that's
Awesome.
maybe if we have 2 more minutes left, there are some questions left.
Sure. Does anybody want to jump in?
That was
I think
incredible.
it's great.
Thank you.
Yeah, please go ahead.
I just wanted to thank Eelco. That was amazing.
Thank you.
Mm.
Yeah.
Do you go ahead, Vince? Sorry.
Oh, I was just wondering if you're planning on implementing other imager networks like the ones from University of Calgary or any of those into your timeline viewer.
Yeah, I would love to. They have this Aurora X project where everything is available in databases and APIs, but it's I've looked into it maybe 2 years ago, but it was a little bit too complicated for me at the time. I was working on basic functionality, but maybe at some point we should get somebody maybe to help with that. That would be really good. Yeah.
I have one more question. Do you have desire to have more public users for this software? Or like, are you tracking users in different, kind of categories or?
I'm not really tracking users, so I've kept everything very simple. So I can see how many users visit per day and which countries are they are from and what browser they are using, but nothing more than that. So my idea is basically to keep it as open as possible, and so basically this hosting is paid for partly by my institute and partly by the European Space Agency for the SWAR mission, and they don't ask me to give more detailed information about users. I think I like it that way because you can set up a whole registration system and do surveys and yeah, that I think I could implement all of that, but that would take development time away and time to write documentation. So I haven't gotten to it yet, but also I'm not really that interested, to be honest, because then you also have to worry about how to keep these records safe and permissions and cookie pop-ups and
Yeah.
less accessible. Yeah.
And I think also kind of I had some ulterior motive in saying that of like there in some sense, I think this is super educational, but it's not at a basic level because it doesn't have necessarily all of the descriptions of all of the data.
Yeah.
Although I also kind of think those problems maybe, there may be even AI solutions for some of those problems in the future that it's not there, but it is actually more accessible in some ways. But,
yeah, that's something we're trying to work on as well. So we're working also on a view where you can see all the notifications, and then you get the notification text. Like at this point in time, NOAA or the Met Office put out a warning for G4, and it means that these and these and these systems can be affected. And I'm also working on the Timeline Viewer 2.0 to have a sidebar that can slide in. Basically, if you click on an info button, and then it gives a description of the data set, because some data providers, they ask for this as well. It gives a description of the data set and also a URL where to download the original data, because they don't want people to download it from our HAPI server, because it's sort of a processed version of the data for visualization. They want people to access the netcdf files with all the little flags and details like that. So that is something that has been on my mind, and I've started on implementing as well. But it's going to be in the version 2.
Very cool. Yeah, thank you so much. Thank you. Any final thoughts for Eelco? All right, thank you so much. I do have one final thought about the storm, which is I did want to see if folks might want to get together and kind of discuss storm observations next week, or find some time for that. And yes, also if anybody has to step away, that's totally fine too. So thinking about doing that. There's so many, all these different storms, right? Now we actually can learn more about the solar terrestrial physics, I think, because we are starting to have a set of these really rare large storms, and how they differ is really interesting. So maybe we will reach out, or I know you all have a lot of cool observations, so I wanted to see if people want to talk about it next week at all.
Yeah,
but
I
it's a
took
busy
a lot of
time,
time
so.
in my for my demos, but it would have been nice to also have some time left. But I always
Appreciate it. Okay. All right.
I also just wanted to thank you, Eelco, one more time for being up so late with us, because it is quite late there. And I really appreciate your taking the time to be here for us today.
My pleasure. It's been very nice with all your questions and interaction. Yeah, it's my pleasure.
Thank you so much. I really appreciate it.